Hello and thank you for joining me for another tutorial. I'm Adam with Push the Envelope, the channel that gives you everything artificial intelligence and machine learning. Today we're going to be talking about our very first machine learning package, and that is SciKit-Learn, or commonly known as SKLearn. So SciKit-Learn is more of the basic machine learning models, things like logistic regression, linear regression, decision trees, and it steers away from more of the deep learning stuff, which we'll get into with TensorFlow and PyTorch, things like that. So super useful tool for when you want to use the more basic models for machine learning, and it's super easy to pre-process your data, feed them into models, and train those models. So without further ado, let's get started. All right, swapping over, as you can see, I have a brand new Jupyter notebook up and ready to go. Obviously, the very first thing we need to do is we need to download the package. If you're using Jupyter Notebook, you can download them straight through here using the exclamation mark. And if you're using Anaconda, Conda has its own package management system, so you can Conda install the package. And the package we're going to be installing today is SciKit-Learn. If you're not using Anaconda, you can do the same thing with pip install. And it's going to be SciKit-Learn. I'm not going to download this, obviously, because I have them already installed. But once you download them, we can move on to importing them into our brand new notebook. So I'm going to use an import, and it is SKLearn. Again, SKLearn is shorthand for Scikit-Learn. I'm also going to import some other modules just to help us here. So Matplotlib.pyplot, I'm going to import that as PLT, and I'm also going to import NumPy as NP. If you haven't had any experience with these, I have 2 tutorials up in this same series going over both of these for beginners. Highly recommend checking those out and learning how to use them. For this, you probably don't need to know too in depth of these modules, but it's always good to learn both of those since they are typically used a lot when you start looking at data. Okay, now I'm going to structure this tutorial more towards a machine learning approach. So getting your data, pre-processing your data, training models, and then predicting off of those. So first thing, obviously, we need to do is we need to start pre-processing our data to get it ready to be fed into a machine learning algorithm. To do this, SKLearn has a whole bunch of different modules to help us clean up our data and structure it properly. So I'm going to import some more modules here. I'm going to say from SKLearn, and I want the model selection module. I want to import the train test split function, and I'm also going to import some pre-processing modules. So say pre-processing. So sklearn.preprocessing. I want to import normalize, and we can go ahead and just start creating some data here. So I'm going to make some random data using NumPy. So numpy.random.randint. I'm just going to get some random integers from 0 to 100, and I want that shape to be 1,000 data points, and I want 20 features per each data point. And then to go with that, I'm going to do just a simple binary classification. So I need a whole bunch of labels for 0 and 1 to go along with our data. Again, going to use NumPy to give me some random integers. Let me correct that here. So I want numbers from 0 to 2. 2 is not going to be included, so it's just going to give me a whole bunch of zeros and ones. And I need to match the amount of data here with the amount of data I created for X. So in this case, it's going to be 1,000 data points. So I will go ahead and print the shapes of those just so you can see. So x.shape, y.shape. And you can see X is 1,000 data points with 20 features, and Y is the associated 1,000 labels to go along with it. First thing I can show you here is typically when you start feeding data into it, you want to try to scale your data or normalize your data. Very easy with SKLearn. So I'm just going to create another variable called xNormalized, and I'm going to use that function I just imported. So sorry, normalize, and I'm going to pass it x. So it's just going to take whatever input and it's going to normalize it. I'm also going to, in here, just break up my outputs a little bit so we don't run into each other. But next, what you want to do typically is you want to split up your data into training and testing sets. So I'm going to define a whole bunch of variables here. So I have a variable for the training x values, the testing x values, the y training values, and the y test values. And it's going to import those right out using the train test split function that I just imported. And what it's looking for is it's looking for the x and y values and how much to split them by. So I'm going to import that normalized data. So for the values of x, I'm using x normalized. For the values of y, I'm using y. And I'm going to say that I want my test size. Let me back up here. So test underscore size, I want it to be equal to 20%. So I want 20% of my data used for the test data. Okay, so now if I jump down to the bottom, I can just print the size of each of those just to make sure that I have the data in the proper format and split correctly. Missing a dot shape right here. And printing that out, you can see the original 1,000 data points were split into 800 training data points and 200 testing data points, along with those same shape for the labels. Okay, now next step would be to import this data into a whole bunch of different models that you want to use. SKLearn, again, is packed with a whole bunch of the basic ones. I am not going to sit here and type out all of these. I'm just going to copy from another notebook I have open into here, and I'm just going to go through what each of these are. I'll kind of add some lines here so you can get away from my face down there. And what you can see is, so you can import linear models, and within the linear models module, there is logistic regression, linear regression, SGD classifier. Again, these are not going to be every single thing you can import. These are just some of the more common ones you can use. Definitely look up the documentation for SKLearn to get a more complete view of all the models you can use. There's also a very cool graphic that shows you based on whatever problem you're trying to solve and how you're trying to use the model and how much data you have and a whole bunch of different other parameters. It's kind of like a decision tree to figure out which models will work best for you. I can put a link to that in the description, and it's a useful tool to figure out which models that you can use within SKLearn. Moving down, you can import decision tree classifiers from the tree module, from the ensemble module. That's where you can get your random forest, your AdaBoost models. Naive Bayes, you can import Gaussian naive Bayes, and neighbors, you can import KNN or K-nearest neighbors classifiers. Again, this is not a holistic list here. Definitely check out the documentation to get a more general idea of what you can do with it. For now, I'm just going to pick one of these. We'll just say we'll move forward with the decision tree. So I'm going to define a new model called CLF for classifier, and I'm going to say this is going to be equal to the decision tree classifier, and just to make it repeatable, I'm just going to say random state equals 1. So this just, when you define the decision tree, there's some inherent randomness to it, and I'm just going to fix that with this random state here. So again, we just pre-processed our data. Now, the very first thing that you're going to need to do is you are going to need to fit that data that you just split out into your model. So you can do that very simple through SKLearn using CLF, that model I just defined, .fit. And fit is going to fit the X data, so in this case X training data, and it's going to fit it with the Y training data to come out with some answer. And I'm just going to print done whenever it's done training. It should go very fast since we don't have much data here, not a lot of features. Yeah, it was almost instant here. But now we have fit our training data to our classifier. And again, the next step is we want to use some metric to determine how well it fit to our data and how well it is able to predict. So SKLearn has a whole bunch of modules for that. In the SKLearn.metrics module, and we are going to import a couple you can use here. So accuracy score, accuracy underscore score, classification underscore report. We can also do a confusion underscore matrix. So just different ways of displaying how well our model is doing. Now, we need to start using that testing data that we just split out in order to use these tools. So I'm going to make a new variable called predictions, or preds. And I'm going to say that's equal to the classifier, CLF, and I'll get my mouse out of the way here, dot predict. So we're going to start predicting some of that testing data. So predict is looking for our X data, our X test data. So I'm going to pass that into it. And it's going to spit out what all the predictions are. And since this is a binary classification, it should be printing out a whole bunch of zeros and ones depending on what class it thinks it is. Now, in order to see the progress and see how well it did fit, we can go ahead and start using some of those modules. So I'm going to print the accuracy score, and I need to pass it what it predicted and what the true values were. So that's where those test, y-test variables come in. In addition to this, we can print some of the other ones, such as the classification report. Let me just make sure I spelled that right. Classification report, again, it's looking for what was predicted and what the true values were. And lastly, we can go ahead and print the confusion matrix, passing it the predictions and what the true values were. So I will go ahead and run all those. And you can see the very first one, accuracy score, it is predicting at 53% accuracy. Again, I'm using random data, so essentially a coin flip would be able to, would be the accuracy that would be getting, which is 53% here. I may not have exactly 50-50 in there. Moving down to the classification report, this shows you things like the precision, the recall, the F1 score, along with the accuracy and some other metrics that you can use. Pretty useful tool here. And lastly, the confusion matrix shows your true positives, true negatives, along with your false positives and false negatives. So different ways of printing out your classification accuracy. Another thing that you can do is you can use cross-validation score to give you the updated accuracy as you're training. So from SKLearn, again, model selection, we are going to import kfold, and we are going to import cross-val score. Okay, so kfold is how many times you're going to be folding your data. So I'm going to make a new value called kfold, and that's going to be equal to that function we just imported. And it's looking for how many times we want to split the data. So I'm going to say number of splits equals 5. Okay, so we're going to be going through this 5 times, and now we need to start training the model. So I'm going to say for train test, we are in kfold.split. So it's going to split out each of those folds, and we're going to pass it in the original data, so the X normalized data, because it's going to be doing the splitting for us. And within this for loop, we are going to be looking at the accuracy. So I'm going to save the accuracy as a ACC, and we're going to do the classifier, and we're going to start fitting the data. So we're going to fit it with, and what this is doing here is giving us the index for the training and test data. So we are going to pass it X normalized, and we're going to pass it at those indices. So for the training data, we're going to pass it in the training. And for the Y, again, we're going to pass it in the training indices. And then we're going to do a dot score to score how well this is fitting. And we're going to do, again, the same thing. I'm just going to copy this over and put it here at the end. But instead of using the training indices, we're going to be scoring it with the testing indices. And we're just going to go ahead and print out the accuracy as it does this. So you can see as it's iterating through those folds, it's giving us an updated accuracy. Now another way you can do this, let me just print a divider here. I can actually say I want to print the cross-val score, and I'm going to pass it whatever classifier I'm using, in this case CLF. I'm going to pass it my data, so this is the normalized x-normalized data, and I'm going to pass it the y data as well. And here is where I can actually use however many folds that I want to use. In this case, we created that variable for k-fold, which was 5 splits. So instead of doing this for loop, this is what cross-val score is going to do for you, and it's going to just save those in an array. If I print that, you can see it's those same exact values just stored in a way. So it makes it easier to iterate upon your data and save those accuracy scores along the way. Okay, so as you iterate through your machine learning process, you're going to be trying to increase the output of your model. And ways to do that obviously are, updating your data, enhancing your data, but other things are you have a lot of parameters that can go into these models, and you want to kind of find the optimal set of parameters. Now, there are a lot of parameters, so it's going to take you a while to figure out exactly which combination is the correct one to use or the most accurate. So SciKit-Learn actually has a lot of built-in features to help you kind of get through those parameters. So again, through the model selection module, we are going to import grid search CV, and we are also going to import randomized search CV. So 2 ways of going through all of those parameters and figuring out which ones are going to get us the best results. Since we're using decision tree has just a long list of different things you can pass into the model in order to figure out if it is right for you or not. So I'm just going to look at some of those, just a tiny subsection of those parameters, and I'm going to define a dictionary. Starting, the keys are going to be whatever those parameter names are. So max features is one of them that we can use, and max features is going to be linked to just a list of which ones I want to start looking at. So I can say I want to look at the square root of all the features, and I want to look at the log of all the features. Now I can look at multiple different parameters that I should be diving into to figure out the optimal path here. So I can say max depth. Sorry, let me make this a string. So this is max underscore depth. And our max depth, we can look at a few here. So let's say 10, 20, and 30, just to give us something to look at. And the last one we'll do a min samples split. So minimum number of samples that are being split. And we're just going to say look at 2 and 5. Now, the first one that we will dive into will be the grid search. So I'm just going to define a new algorithm name called grid search. And we are going to use the module that we just input. So grid search CV. Now, the first thing it's looking for is whatever estimator you're using, whatever model we're using. And that is going to be, again, the decision tree classifier. Next, it's going to be looking at, okay, which parameters are going to be the ones that we're trying to maximize. So that is the dictionary that we just made. So pass in params. And I want to say, I want you to figure out the optimal parameter solution based on the accuracy. So I'll say score yourself on the accuracy. And like we did up top, we can figure out how many folds that we want to do in the data. Since this is cross-validation, that's what the CV is at the end of these modules. So we can pass in the value of CV as 5. So it's just going to match what we did up top there. And now this is what grid search is doing is it's going to go through all of these different parameters and it's going to test every single one of them. It's going to go through and test square root with 10 depth and 2 min samples, and it's going to go through and do every single combination to figure out which one was best. So if you have a lot of parameters and you have a lot of things that you're trying out, this may take a while. But for now we will do grid search, and now we want to fit our data. So we are going to fit, and we're going to pass it in the original data set, which was x normalized, and we're going to pass it in the y values as well. So that is going to give us the final model, and is going to give us what the best parameters, what the best score was, and what the best parameters were. So if I say grid search, and I want to say what was the best underscore score, this is going to give me what was the best accuracy that we were able to get from it. Also, we can say, I want to say grid search dot, I want to know what the best combination of parameters were. So I can say best underscore params, and I will run this, and I have an error. Sorry, this is not score, this is scoring. So I want to say the scoring will be based on the accuracy. Okay, so what this is telling us is 52% was the best that we were able to get using these parameters here, and here was the best combination of parameters that we were able to find, which was a max steps of 30, max features as log, and the min samples split as 5. So that's an easy way to go through all of these to find the best combinations. Now, if you have a lot of them, grid search is going to take forever because it is going to try to brute force every single combination. So if I take the same one here and let me just split up my data, or split up my output. So I'm going to take the same thing and I'm going to just show you by increasing the number that we're looking at. So I'll add 40 and 50 in here as well. I'll say let's also look at 7 and 10. So now we're really increasing the number of parameters that the model is supposed to be looking at. And if you use grid search, again on this, there's not a lot of data, so it would probably go fairly quickly. But when you have a lot of data and you have a lot of parameters and you're trying to fit it, it's going to take some time using grid search to go through all of them. So you can use random search to help you dig through those in a random order and not necessarily look at every single one. So you can use that through the randomized search CV module. And again, like the grid search, we are looking for the estimator, so decision tree classifier, looking for what parameters that we are going to be looking into, and we are going to be figuring out how we're going to be scoring ourselves by passing the accuracy into here. And lastly, passing in the number of folds, which would be 5. Let me just move this down a little bit so you can see the last thing I passed was 5. So now, again, just like the grid search, we're going to fit the random search, and we're going to fit it with the original X data, which was X normalized, and the Y data. And I'm just going to copy these up here, but again, we're going to be looking for what was the best score we were able to get and what were the best parameters. If I can just change this model. I have an error here. I'm trying to figure out what I did wrong. Oh, sorry. I did not put this needs parentheses at the end right here for the decision tree classifier. Okay, looking back through, I see now what I did. I did not add fit here. I was not fitting the data. I was just straight up calling the classifier that I just made. So if you use the fit, you can fit your X data right in with your Y data. Okay, as you can see, our random search looked at more variables, but in a random order instead of doing every single one. So it didn't hit every single one of them, but it was able to look broadly across. It actually gave us a higher accuracy. It found that one of the depths that I passed in and I didn't pass into the grid search was more of an optimal solution. Now, what I like to do for this is I like to start off with a randomized search over a massive amount of features or parameters to pass it into. And that will give me an idea of, okay, maybe this area was the best. And then I will take what I learned from the random search and I will pass that into the grid search. So I'll start looking around that set of parameters, and maybe I'll look a couple up, a couple down, and see, okay, can I hone in on whatever that max was? It may be a local max, but it will get me there. So that's typically what I will do to try to quickly get to that optimal solution without checking every single combination, that is. So a cool thing about decision trees and SKLearn is they are interpretable. So I can straight up print the entire decision tree to see why it made its decision. So it's very good for explainability. I can do that using SKLearn.tree. And I'm going to import the export underscore tree module. Sorry, not export tree. I'm going to import the export text. So I'm going to give a report that's equal to the export text of the classifier. And I'm just going to print R. And what it's doing is telling me, okay, I didn't give these feature names. These are random features. So it's saying whatever feature 19 was, if it was less than or equal to 0.06, and it's just building out the entire tree to get you whatever your final class was. So like if it made it all the way down here, it's saying this is equal to class 0, and that's how it's making its decisions. Again, I'm using random data, random number of features, so it's not going to be super helpful in our case, but when you start using real problems, it's a great way to check on why it's making its predictions. Another thing that you'll want to know is, okay, you gave me the tree, now what are the most important features for what I was just predicting on? And that is also built right in to the classifier that we just made. So I'm saying the importances is equal to the classifier dot feature underscore importance with another underscore at the end. So this is taking all of the features and it has a value from 0 to 1 based on how important it was to the final prediction. And I'm going to say features is equal to, I'm going to use NumPy to sort these. And I'm going to sort the importances. And I'm going to reverse the array because I want it to be decreasing importance instead of increasing, ascending. So what features is, it's going to be the index of each of the features that were passed. And again, these don't have actual feature names. So I'm just going to make a label for each feature name as a NumPy array. I'm going to give it the feature name of feature number, and then I'm going to say plus the string of x for x in range length of the features. So for each feature, I'm just giving it a feature name. And now what I want to do is I want to use Matplotlib to print a figure with a fig size of 15 by 7. And I'm going to use a bar chart to show this, so plt.bar. Now we have our x variables is just the number of features, so 0 to x number of features. And so we can pass that in as the length of the features. And the y is going to be the importances, but it is going to be the importances sorted. So I need to pass in the indices that I just got from features. So it's taking all the importances and it's sorting them by most important to least important. I'm also going to change the labels to show me the feature names of each of these. So again, it's going to be the length of features, and I'm going to map those to the names that I just created, which was labels, sorted by the indices. And I'm going to do plt.show to print those out. Again, I have an error. I did not set an equal sign here. There we go. Okay, I'm also going to add a rotation in here of 90 degrees just so we can see our labels. So as you can see, it took all of our features, and again, let me get my head out of the way. It took all the features and it mapped them most important to least important using whatever feature name. In this case, I just made random feature names, and for some reason, feature 0 was found to be most important, going down in importance here. So, cool way to figure out what were the important features, why is your model making its predictions. It's super easy for explainability, and that's one of the benefits of using these simple models is you get explainability versus using a neural network. And if you do it as a black box, you're going to have really no idea why it's making its predictions. So the last thing I will show you is SKLearn has a lot of the beginner data sets built right into it. So I can import, data sets. And I would say my data is going to be equal to datasets dot, maybe I want to load digits. So digits is a whole bunch of handwritten digits used for classification. So it's going to be a whole bunch of pixel values that an image classifier can use to determine what the actual digit was supposed to be. So I'm just going to print, first I'll print data. And you can see what it has is it has the data that typically you feed into the classification algorithm. You have the target, so whatever the end label was supposed to be or actually is. You have a whole bunch of other stuff, including the image array, so you could print these out if you wanted to. I'm also going to just show you data.images. I want to know what the shape of each image was. So this is saying there are 1,797 images in there, and each of them are 8 pixels by 8 pixels. So if I use plt.imshow, I want to know what data.images at 0, and I'm going to say that this is in grayscale. And I also want to know, I want to print what the data.target at 0 was. So I want to print what the image was. And I want to know what the actual label for the image was supposed to be. So as you can see, the label is a 0, and you can see this definitely looks like a 0. So that way you can use that to train your image classifier through SKLearn datasets. But that is all I have for SKLearn. Again, super useful tool for more of the basic algorithms. I definitely like to use it, and it has a lot of built-in processing tools, and like this data set, there's a lot more of the beginner-friendly stuff within it. So for now, that's it, and I will see you guys in the next video. Thanks.